Hi. For this video, we'll still be learning about linear inequalities in one variable, but this time our focus will be on properties of inequalities. And then after that, we'll be using it to solve linear inequalities in one variable. Okay, let's have the properties. The first one is addition property of inequalities. If the same term is added to both sides of the inequality, then the solution set to the inequality is unchanged. Okay, so if you notice, this property is very similar with the addition property of equality. In fact, it's the same. Okay, and we use it the same way as we do it with solving equations. Okay, now let's say we have um, x minus 5 is greater than 6. Okay, so if we want to solve for x, we need to cancel out negative 5. And to do that, we need to add 5 to both sides of your inequality. So this one will be 6 plus 5. Now we can cancel out negative 5 here. So we'll only have an x, and then for the other side, we have an 11. Now, based from the given property, if you only do like merely addition of the same number to both sides of your inequality, so we can keep the inequality unchanged. So we still have greater than here. So our final answer is x is greater than 11. Take note that this property is also true with subtraction, since when we do subtraction, right, this is just the same as adding a negative number. Okay, now let's have the second one, multiplication property of inequalities. So when multiplying both sides of the inequality by a constant c, so if your c is greater than 0, meaning it's positive, the direction of the inequality symbol is the same. Now, if you multiply a c that is less than 0, meaning negative number, the direction of inequality symbol is reversed. Let's say we have x is greater than 4. If we multiply a number that is greater than 0, or a positive number, let's say we multiply 5 to both sides of your inequality. So this will become 5x, and for the other side, this will become 20. So from the rule, if you multiply a positive number, then your inequality stays the same. Now, what if we multiply a negative number? Let's multiply negative 5 to both sides of your inequality. So this will become negative 5x, and the other one is negative 20. This time, based on the given property, the inequality should reverse. So instead of having greater than, for your final answer, it should be less than. Okay, so now take note that this property is true to division also. Okay, let's have some examples to solve. So the first one is 4 times 2x minus 3 plus 2 times quantity 1 minus 2x is less than or equal to 2x minus 5. So let us distribute 4 first to 2x minus 3. Okay, so you have 4 times 2x, that is 8x. And then 4 times negative 3 is negative 12. Next, let's distribute 2 to 1 minus 2x. So you have 2 times 1 is 2. Next, 2 times negative 2x is negative 4x. And then for the other side, we just copy them, 2x minus 5. So let's simplify the left side. You will have 8x minus 4x. So that is 4x. And then negative 12 plus 2 is negative 10. is less than or equal to 2x minus 5. Now let us combine like terms. Let's transpose 2x to the left side. So that would be 4x minus 2x, which is 2x. Next, transpose negative 10 to the right side. You will have negative 5 plus 10, which is 5. And then divide both sides by 2 so that we can cancel out this one. And we only have an x, which is less than or equal to 5 over 2, or 2.5. And that's our final answer. Okay, let's have the second example. So this time we have 1/2 times quantity 1 minus 2x is greater than 2/3 x plus 2. So we have fractions here. So we can just solve it, straight like this one, or we can multiply it by 6 so that we can cancel out your denominator. Let's do it that way so we don't have fractions anymore. So let's multiply 6 to both sides your inequality. So you have 6 times 1/2, so that is 3, right? Times 1 minus 2x is greater than. Now 6 times 2/3 x, so that is 12 over 3 is 4x. And then 2 times 6 is 12. Then after that, let's distribute 3 to 1 minus 2x. So this is 3 times 1 is 3, and then 3 times negative 2x is negative 6x is greater than 4x plus 12. Now let's combine like terms. So you will have here negative 6x. If we transpose 4x to the other side, that would be negative 4x is greater than 12. Transpose 3 to the right side, that would be negative 3. So this is negative 10x is greater than 9. So as you can see, we will divide both sides by a negative number, which is negative 10. Recall that from the given property, if we divide it by a negative number, your inequality will reverse. So this one, so we cancel out negative 10 here. So we'll be left with x, but from greater than, your inequality symbol should reverse and will become less than. And then negative 9 over 10. Okay, let's have the last example. So we have here x minus 5.2 is not equal to 1.05 plus 0.5x. You see the given is in decimal. So some of my students, they don't like solving equations or the sum inequalities involving decimals. So of course you can just solve it straight like this. But if you want it to be in a whole number, you can just multiply it by either a 10 or 100, depends on your given. So here we have 2 decimal places, right? At most, the 1.05. So I will multiply this inequality by 100 so that all the numbers will be in whole number. So let's do that. So this one, your x will become 100x minus 5.2 times 100, so that is 520, is not equal to 1.05 times 100 is 105, plus 0.5x times 100 is 50x. So this time it looks simpler, right? So now let's combine like terms. So I'll transpose 50x to the left side. So this would be 100x minus 50x. And then for the right side, you will have 105. And if you transpose negative 520 to the right side, that is plus 520. So simplifying it, 100x minus 50x is 50x. Is not equal to 105 plus 520. This is 625. 12.5. Now to simplify, let's divide both sides by 50. So we can cancel 50 here, we'll be left with an x, and then not equal to 625 over 50. If we simplify this, it is 25 over 2, or in decimal 12.5. Okay, so that's it for this lesson, for this video. I hope you learned something. See you again on our next video. Thank you.